Let's take a look at an example of how to use the chain rule in order to help us find the location of horizontal tangents to a curve. Now remember that if we're going to have a horizontal tangent to a curve, that means that the derivative there is going to equal 0. So what we're going to have to do is find the derivative of this given function, set it equal to 0, and solve it. So derivative of sine is cosine, so we'd start out having 2 cosine of x. Now for the term after the plus sign, sine squared of x, that's sine of x, the quantity squared. That's a chain rule part. Alright, so you have to think through how to do the chain rule. So if we started on the outside, we'd have 2 sine of x, but then we have to multiply by the derivative of sine, which is going to be cosine. And this is what we're setting equal to 0. Now it becomes a trig equation to solve. Notice that we do have a greatest common factor in cosine, so let's factor that out. Actually, we can pull the 2 as well. So we have 2 cosine of x as our greatest common factor. That is multiplied by 1 plus sine of x. And of course you can use the distributive property to check to make sure that is correct. So according to the zero product property, we have 2 cosine of x equals 0. So we'll solve that in just a second. We have 1 plus sine of x equals 0, and we shall solve that as well. So over on the left, of course, if we divide out the 2, we're looking at cosine of x equaling 0. Now, think of your unit circle, and think about where cosine equals 0. That's going to happen at the top of the circle at pi over 2, and at the bottom of the circle at 3 pi over 2. We are, of course, assuming in this problem we're just talking about angles from 0 to 2 pi. I guess we should have stated that from the beginning. Because, of course, there are going to be infinitely many angles that have a cosine of 0. But if we just think of one complete circle from 0 to 2 pi, we would have pi over 2 and 3 pi over 2. Now, on the other side, on the right, we need to think about where it is that sine of x is equal to negative 1. Well, that's happening at the bottom of the circle as well at 3 pi over 2. So 3 pi over 2 does show up twice as an answer. So here we have 2 locations in between 0 and 2 pi on this particular curve at which we would have horizontal tangents. Of course, you can graph it on your graphing calculator to confirm it and check it graphically to make sure what you did algebraically is correct.